Hi everyone, in this video we're going to look at the hydration of alkenes to form alcohols. You can see there we've got the general reaction of an unsymmetrical alkene, the simplest being propene, and when that reacts with water in the presence of a strong acid catalyst like sulfuric acid, we tend to get the major product being propan 2-ol, minor product being propan 1-ol. Again, we call this a regioselective reaction. Regioselective means one structural isomer is formed in preference to the other one. Let's have a look at the mechanistic details of this reaction. So let's look at propene. Let's sort of cut and paste propene. And let's just say that this comes from this protonated water molecule. This protonated water molecule has got the proton from sulfuric acid. So let's just briefly explain that. We said that the H plus comes from H2SO4, so what's in effect happened is the H2SO4 we can think of as reacts with the water to form H3O plus and a HSO4 minus ion. So what we get then is the normal electrophilic addition, where the pair of electrons from the pi bond attack the delta positive hydrogen, and we get the following curly arrows. This then produces again a carbocation intermediate. Again, I'm just going to show the formation of the carbocation intermediate, which leads to the major product. So this would be formed by a secondary carbocation intermediate. So in this case, the hydrogen will add to the carbon with the most hydrogens already attached, as per Markovnikov's rule, and that gives us my secondary carbocation intermediate, which again is more stable than my primary carbocation intermediate, which would be formed if the hydrogen was to have attached to this carbon. Now, what happens next is very dependent on the concentration of the sulfuric acid. In dilute sulfuric acid, what would happen now is that the water molecule would come along and attack this, and you'd get your propan 2-ol formed. And that's your product, again, which is the same as what we've said here. Major product formed by the more stable secondary carbocation. And this occurs when you've got a dilute sulfuric acid. Just be aware that in concentrated sulfuric acid, what would tend to happen is the hydrogen sulfate ion here would actually react as a nucleophile. So this is what would happen in dilute acid. Let's just copy and paste this. So this is in dilute acid. In concentrated acid, you'd have a much higher concentration of this HSO4. So what you would then get, instead of this being a water molecule, you'd get this O minus ion. So this is your HSO4 minus, and you'd actually get this occurring. And instead of the OH there, you'd get this O SO2OH, this ethyl, or in this case, this propyl hydrogen sulfate. What usually happens then is this then does react. This can then be hydrolyzed with water, and you would get then propan 2-ol, just in the same way as you've got propan 2-ol here. This mechanism here would just be a standard nucleophilic substitution, where the lone pair of the water would simply attack and do something like this. So that there is the hydration of an alkene.